Really interesting. One day I was out walking across the site and I actually just fell into the material. It was like quicksand from a Tarzan movie. And our client, Kit Hamby, took a picture of me before he pulled me out of the silt. And this actually occurred before we even found any of the bones.
The bones were encountered basically within those reservoir sediments that we had to remove as part of the construction. So in 2010, we identified that all this material had to be removed from site and decided to start the construction process early.
Fortunately for us, the project didn't need to be re-engineered. What we were doing was excavating through what we call unsuitable building materials. This was the silt and the peat layer where these bones or the animals were located. And we were trying to found our dam on the glacial till. And the scientists were also trying to get to the glacial till. So the glacial till was formed by, the first set of glaciers that came through maybe on the order of 150,000 years ago. And so they knew that these animals lived in the last 40 to 80,000 years. So we knew that from a geologic perspective, we would find these animals above that layer. So we were all wanting to get down to that level.
Going into construction 2011, we were all greatly anticipating just how the museum was going to move all the material. And so at our weekly meetings, I had to put together a spreadsheet that more or less showed volume of dirt moved versus what we had to expose the foundation of the dam. And the first couple weeks were a little bit concerning because we weren't moving very much material. We might be moving about 4 or 5 cubic yards a day versus needing to move almost 7,000 over a 45-day period. So that was kind of fun, just seeing how that rolled out and seeing how the district stepped up to help them out and just move material. And so I think just watching scientists working with engineers and working with an owner of a project was very rewarding, just to see that it could be a success, and that in the future when problems like this are encountered that involve scientific discoveries, we don't necessarily need to step down and assume that the project's going to come to a standstill, and people do want to see a success.
It was challenging in some ways because the museum was there excavating all these bones, and I was there trying to make sure that we were getting down deep enough to the glacial till and to ensure that there was nothing that we had missed and that we'd taken out all the unsuitable material from beneath the embankment.
Just the science and the people that were brought to the site and all the knowledge that they had, unique pieces of equipment for carbon dating, or also just dating the sediments that were older than 43,500 years old. Carbon dating only gets you to 43,500 years, and so you need to use unique techniques for older sediments. But there were also people brought in from universities that just had specific knowledge in areas, and so to be able to talk to people like that and just understand their story a little bit, for the brief time that people are passing, or you get to meet on a project, is just fascinating to me.
Because everyone wanted this to be a success, and I think soon into construction we realized everyone did want this to be a success, and so it was just neat to see how everyone worked together, and not just work together, but we were interested in what each organization was doing. I think learning about the scientific discoveries as well as the scientists learning about the engineering just built a greater appreciation for the project, and it just got us all on the same team working together.
When the Denver Museum of Nature and Science personnel showed up on site, there were these group of people that are used to doing paleontological and archaeological digs where they're the only ones on the site. And in this particular instance, we had a very tight construction area. We were working in an area about the size of a football field, where we had to excavate approximately a 35-foot deep hole in this area. And so the museum people wanted to do the science, and we needed to get the material out of that hole. And so there was this inherent conflict of, how do we both, achieve our goals? But the Denver Museum of Nature and Science, they're used to working with shovels and, brushes and just small tools to excavate these bones. And we have to excavate a 35-foot deep hole. And so we did find a way to bring in smaller equipment to work alongside of them and do it in a safe manner. The museum had their own professional staff, but also an army of volunteers, and on any given week, they had about 50 volunteers on site. So we developed a health and safety plan so that when people came on site, and they were bringing teachers and various people to learn about the site, but this segment of society is just not used to working around heavy equipment, construction sites, safety, and so we had to train them.
I'm an engineer, but I'm an aeronautical engineer, so I work in a lab or in wind tunnels, and I had never been on a real construction site before where there's heavy equipment and where you're moving dirt, what I call real man engineering. So to go onto this site and to be part of a team as all of these earth movers and people, engineers were there moving literally thousands of yards of dirt and constructing a dam was something I had never experienced. The visceral feel of these giant machines and the scale of this was something that I'd never experienced before, and certainly none of the other museum people.
A health and safety plan was developed by us to help just facilitate each organization with understanding of different project constraints and safety issues that they should be aware of. Each organization actually took responsibility for their safety.
The project, their contract price for the entire project was $3.9 million. And so by finishing the project, about $4,000 over that price was an extreme event, not just with finding a world-class site, but also, just any construction project to be less than a percentage over your contract price is attributable to everybody that was involved, including the contractors.
The Snowmass Village site was unique in that it was a public construction project, a reservoir and a dam, but it was also a science site for paleontology and archaeology. And at the time, we really didn't know how important it would be in that respect, but we had a pretty good idea. So we had to totally depend upon the engineers who were building the dam, excavating the project for what they knew about the site, what the strata were, how far down we had to go, how far out we could go, and then basically we had to chase the fossils wherever they went. And luckily we were able to find congruence between their goals and our goals. And for our paleontologists, this was the first time they'd ever worked directly with engineers on a project like this, and we're able to pull it off both financially and operationally so that everyone met their goals.
I was out at the site just a couple days ago, and it was half filled with water, and I can just look out and just picture 70 people working at pulling bones out of the ground in the one area, and then just thinking 1 to 2 months down the road how the site had totally evolved into a blown out construction project where scrapers and all kinds of heavy equipment was building a dam, and just it was really rewarding to see how all that happened in such a short period of time, and now it's being filled with water.
We're standing in the oldest building in the museum complex. It's the original 1908 building. Most of its life it was used as a dinosaur hall until 1995, and then since 95 it's been used for storage of packing materials and occasional bones and maps. But after the Snowmass Village find, it has become the repository for most of the 5,500 bones of mammoths, mastodons, deer that we pulled off the Snowmass Village site. And the instant you walk in this room, you know that it's a place of magic as you gaze around and look at these bones.
In those dry periods that we might run into in the future, dry or low stream flows. And it's not only a real positive environmental project because it's going to help protect the stream, but it will help us in the future if we have any global warming issues or drought periods.
You walk up there, and we walked out to where the bulldozer the day before had just clipped the top of this first mammoth. And we were, walking across the site, and I just had this feeling that came over to me that I was walking into history that day. We have all these people, and you could just tell that everybody was excited about the whole project.
The Snowmass Village find was important to us on a couple different dimensions. First was it's the finest high altitude Ice Age site in the world. It's the only time we found a record of Ice Age animals, both plants and animals, at altitude over a 100,000 year period. So it's a perfect record of everything that happened in the Colorado Rockies from 150,000 years ago to 50,000 years ago. We've never had that before. We've never been able to determine what animals lived here, what the makeup of the plant life was. Was it forested? Was it grasslands? And now we have an absolute perfect record of that. So from a scientific point of view, this was unique in the world. And for the first time, we can tell what it was like here. And that's important because from a climate point of view, the Earth went through a heating period to where it was warmer than it is now, and went through a cooling period to where it's colder than it is now. And we have a record of all of that.